So how do we know if we have an inverse function for a given function? Well, a function, two conditions. A function will have an inverse if and only if it's 1-to-1. Okay, well, that's the condition, if and only if. So if it's 1-to-1, it is an inverse. If it's an inverse, if it has an inverse, then it's 1-to-1. So that's the if and only if part. Now, how can we tell if it's 1-to-1? Well, if it's strictly monotonic, then it's 1-to-1. Okay, now strictly monotonic means, graphically, you can see it. Strictly monotonic means it's always either non-increasing or non-decreasing. Okay, so it's always one or the other. Monotonic looks like this. Comes up like that. Okay, where it's always increasing, or you might have something that looks like this. So it's always going downward. That's what strictly monotonic means. Now, 1-to-1 means, well, you know what a function means. If f is a function of x, then for every x in the domain, there's exactly one y associated with that x in the domain. And for it to be 1-to-1 means that for every y value in the range is associated with exactly one value in the domain. So functions can look like this. Okay, that can be a function, but this will not be. This is not a 1-to-1 function, because for a given value of y, let's say here, there are actually two x's that are associated with that. So this is an example of not 1-to-1. Okay, so we can't have this situation and expect there to be an inverse. Even though it's a function, it will not have an inverse. So that's now. Here's a condition for 1-to-1-ness. If it's strictly monotonic on its entire domain, then it will be a 1-to-1 function. So again, strictly monotonic means it's either always increasing or always decreasing. So you'll never have, you'll always have, for one x, you have exactly one y, and for one y, it's associated with a single x, exactly one x value. So, and I just mentioned a note here that if it's 1-to-1, that doesn't mean necessarily that it's strictly monotonic. I've got a couple of examples. An example over here, this one, and it shows here is a function that is 1-to-1. Okay, in other words, it's coming in. And it's not monotonic. Okay, it's not strictly monotonic. So this is a weird situation, but this would still have an inverse. Okay, since it is 1-to-1. Anyway, we have another test that we can use, the horizontal line test, and it says that if you can, in one way to state it is that if a horizontal line cannot be drawn to intersect the graph of a function in more than one place, then that function would be considered 1-to-1, and then therefore would have an inverse. So, example like that parabola fails the horizontal line test right there. I drew a line crossed in two places. Function like this, try to draw that line, it's only going to cut in one place. Okay, that would be 1-to-1. Okay, so it would have an inverse.